This is my CS437 submission for Lab 2, IoT Networking, and my name is Ana Elisa Cabrera. First, I established a Bluetooth connection. I connected my Raspberry Pi to my Galaxy. I started the server on my Raspberry Pi. I ran the Flutter app to start the client, and I launched the app. I started the chat, and now I am ready to write the message to my Raspberry Pi. So I type it, I send it, and you can see on the terminal that the Raspberry Pi received it. Hello, it's me. You can see it there, and you can see it there. I will try this again with another test. Hello from the other side, hello from the other side, and I will try another one. Hi. And finally, CS437 rocks. I wrote my code in the app page file written in the Dart programming language. I started by editing the scaffold. The scaffold, a class in Flutter that provides many widgets APIs, is a framework to implement the basic material design layer of the app. When returned, scaffold expands to occupy the whole device screen. The particular scaffold that I am editing is this one, initiated after the user presses the Start Chat button in the home screen. I wanted to add a text box to the chat page. Inside this text field, I wanted there to be a send button where the user could type their information and send it at the click of a button. But in order to do that, I have to include this parameter called the controller. And this controller is initiated here. This variable creates a text editing controller that stores text at the user input. After the user writes their message, it gets stored in this controller, and then on click, it sends the user input to the server. And I want the user to be able to send many messages at once without having to restart everything. So to make this possible, I make sure that the information inside this controller is disposed as soon as the user sends it to the server. To achieve successful Bluetooth connection, I implemented this Bluetooth COM API program written in Python. From blue.btcom, I imported Bluetooth server. And from Signal, I imported pause. This file is written and run on the Raspberry Pi server, and it contains a function that lets the server handle data received from the client. The data that the server received from the client is the same user input written in the text box and sent with a click of the button that I coded in the app page scaffold. I made this client message variable where I put my name and the message that I sent to the Raspberry Pi. I made a server message variable that is a friendly reply from the PiCar. I made this interaction variable where I combine both of them. I want this to display as in a chat format. This is returned and displayed here. This allows the user of the Android app to see that the Raspberry Pi received their message, and at the same time, they can receive a message themselves from the Raspberry Pi. Main.javascript file. This script is the entry point of an Electron application, and it controls the main process, which runs in a full node JavaScript environment. It creates a window and it renders the whole application page. This is my index.html file. So at the top of my web service application, you can see the picture of a smart car. It also shows the version of Node.js, Chromium, and Electron that your Electron app is using. Below the car picture, there are two columns. On the left side of the column, you will have the controller, and there's an up arrow, a left arrow, a right arrow, a down arrow, and right in the middle there is a stop button. So each of these buttons that form part of the controller have their respective functions that are defined in the index.javascript file. On the right column, you have an input text box, and you also have like different bullet points that each describe a different information from the PiCar. I decided to display car direction, speed, obstacle detection, and obstacle distance. Index.javascript. This program has a client function. It takes user input that was written in a text box and sent to the Raspberry Pi, but by the web service user, and it establishes a client, which starts the client-server connection. And then the client writes the user input and sends it to the Raspberry Pi. User input can be sent to the Raspberry Pi in different ways. It can be written in the text box and sent to the Raspberry Pi that way, which is what client function handles, or it can be sent by clicking one of the arrows or the stop button in the remote controller on the left side of column of my web service. So when a user clicks the up arrow, it calls the move forward function and sends the word forward to the Raspberry Pi. If the user clicks the back arrow, it calls the move backwards function and sends the word backward to the Raspberry Pi. When the user clicks the left arrow, it calls the move left function and sends the word left to the Raspberry Pi. When the user clicks the right arrow, it calls the move right function and sends the word right to the Raspberry Pi. And then finally, when the user clicks the middle stop button, it calls the stop function and sends the word stop to the Raspberry Pi. Likewise, the user can just type any of these keywords and it would do the same thing. In this Wi-Fi server Python script, I tell the Raspberry Pi what to do with the information it receives from the client. As long as the client sends a message that isn't blank, if the Raspberry Pi receives the words forward, up, or straight from the client, it prompts the PiCar to move forward. Similarly, if it receives the keywords backward, back, down, or reverse from either the text box or the click of the arrow, the click of the back arrow, then it prompts the PiCar to move backwards. If it receives the keyword left, then it prompts the PiCar to turn left. If it receives the keyword right, then it prompts the PiCar to move right. If it receives the keyword stop, then it prompts the PiCar to stop. In a text box, the user might input different words like help or start so that they can know what to do. And then it returns a message of the kind of commands that the person can input in order to get the car to move. If the input is anything else, it could be a message or any string, then no information can be displayed from the PiCar because it has not been started. And it just returns what the user wrote to the Raspberry Pi. And it gives them instructions to just write help so that they know how to start the car. At the end of each condition, the PiCar ultimately sends a message back to the client. It's the status of all the PiCar variables that we need. The client then gets that data from the server, and then it splits the returned string with all the PiCar status values into an array. This makes it very easy to index an array and extract the exact information you need and display it right next to these bullet points on the right side column of the web service. The first element contains the PiCar direction, the second element contains the PiCar speed, the third element contains if the obstacle is detected, could be yes, no, or too far. The fourth item of status shows the obstacle distance in centimeters. And finally, the fifth item in status shows the message from the Raspberry Pi. The client connection ends, and the client activity gets destroyed. For all my other functions, they follow the exact same logic as client, except at the very end, I call back client again. So that this way, I don't have to restart the client or server each time the user sends a message to the Pi. This allows the user to send multiple messages to the Raspberry Pi. It can click any arrow it wants, like right after the other, very fast, and then the PiCar will follow without hesitating. Here are my results. Test 1. Let's press any key to start the PiCar. Let's turn it left. Let's stop it. The web service updates the PiCar information. Raspberry Pi replied, PiCar completely stopped, car direction, idle, speed 0, obstacle detected, no, too far, obstacle distance 54.2 centimeters. Let's turn the car right now and stop it. Let's move it forward. Let's freeze while the PiCar is in motion. Raspberry Pi replied, PiCar is moving forward. Caution, obstacle detected. Car direction forward, speed 10. Obstacle detected, yes. Obstacle distance 2 centimeters. The user can ignore your message and crash, like I did it. I'm going to move the car backwards and then stop it. Forward again. Move it to the left. Move it to the right. And just read the last recording. Raspberry Pi replied, PiCar is moving right. No obstacles detected. Car direction right. Speed 10. Obstacle detected? No. Obstacle distance 26.2 centimeters. Test 2. I will test drive the PiCar, and you can sit back and observe. The end.